Okay, so today we're going to be looking at solving some indecimal equations using logs and exponentials, which is, it's not hard, you just need to practice because like I've been saying, there's a couple of tricks in there that you need to be aware of. Okay, so first thing we're going to do is solve A. So we've got 4 with 3x above it times 16 to the power of 3 minus x is equal to 256. So first thing I'm going to do is I can look at this, and because they're multiplying and they're equal to this, I'm going to assume that they can all be expressed as 4 to the power of something. Now, if I wasn't going to be able to do it with 4 to the power of something, they could also be expressed as 2 to the power of something, because I know that this is 2 to the power of 2, and this is 2 to the power of 4, and this is 2 to the power of something. I can't remember off the top of my head. But we're going to go through and we're going to try 4 to the power first. So the first term won't change. 16 can be represented as 4 to the power of 2. The power that was there before will go in a bracket. Is equal to now 256 is 4 to the power of 4. Okay, a way that I like to do that in my head is I would do 4 times 4 makes 16 times 4 again, work that answer out, and then just keep multiplying things by 4 until I work out how many times I have to multiply it by 4 to get that number. Okay, so because these two things now have the same base and they're multiplying, I can add the bases, I can add the powers together. So this will become 4 to the power of 3x and plus, now I'm going to expand this bracket at the same time, so 2 times 3 makes 6 minus 2x is equal to 4 to the power of 4. Okay, I'm going to take this 4 to the other side by using log with base 4. Now, when I do that, that is going to cancel this section out. So I'm left with, I'll group this together at the same time, 3x minus 2x will make x plus the 6. This 4 has been moved across by changing it to log 4 because it was a base of an exponential over here. It becomes the base of a log over here. So that log 4 base cancels out the 4 exponential, and I'm left with just this power above it. Okay, so I'm left with x plus 6 equals 4, meaning I can take this to the other side. It was add 6, so now it's subtract 6, meaning that I'm left with x equals negative 2. Okay, B. 7x to the power of negative 3 minus 3 is equal to 0. Now, I can't make these things have the same base, doesn't matter how hard you try. So my next step is that I'm going to take this one to the other side. It was add 3, so now it's plus 3. That leaves me with 7 to the power of x minus 3, and then I've got the 3 on the other side. So to change this away from being being an exponential, I'm going to take this base, and it's going to become log 7, or log with base 7, 3. So log 7, 3 is equal to x minus 3. Next thing I'm going to do is take this 3 to the other side, which will leave me with x is equal to log 7, 3 plus 3. Okay, and I'm going to leave it like that. Now, it does say to give an exact form, so this is the exact form. If I put it in my calculator, I'm going to get a rounded answer. Now, you could change this so that they have the logs as well, but there's really no point. This is going to be the simplest form that we want. Okay, C. Now I've got 2 brackets, which indicates to us that we're going to be using null factor rule to solve this. Now, this is one of the tricks that we commonly use. Now, so I'm going to use null factor rule. 5x minus 25 is equal to 0. And the other one will be 5x plus 1 is equal to 0. First thing I'm going to do is take this one to the other side, which will change it to positive 1. Now I've got 5x is equal to 1. So I'll take the 5 across. He was the base over here, meaning that he'll be the base of the log over here. So log 5, 1 is equal to x. Now, I can simplify this further because I know this rule. If I think about what makes this statement true, the only thing that will make 5 to the power of something equal 1 is if x is equal to 0. Okay, now we can start solving the other one. Now, I've just realised that that is not actually a plus. Sorry, that's not a minus. It's just when I circled it. So that will make this one over here -1, which will make this -1, meaning that this one will give you a math error, not 0, because I can't have a negative in this position. There is no power here that will make that statement true. Okay, so let's solve the next one. 5x is equal to 25 when I move this across. Now, I could say that 25 is represented as 5 to the power of 2. So then I can see from this point that x is equal to 2. C. Okay. Oh, that was C. D. Now, D is one of my favorites because, like I keep saying, everything in methods turns into a quadratic. It's really important to know your quadratics. So here you can see I've got 3 to the power of 2x, and then over here I've got 3 to the power of x. Now, that's your first hint that we're going to let a equal 3 to the power of x. Now, when I replace that in this first section, that'll give me a squared minus 9a plus 14 is equal to 0. So using that, I can now look for my factors that'll make this true. So it's looking for two numbers that multiply to give me 14 and add to give me -9. So my factors of 14 are 7 and 2. And if I make them both negative, they'll add to give me -9 and they'll multiply to give me positive 14. So I'm going to replace that in the brackets, let it equal 0. And now I can say that therefore a is equal to either 7 or it could be equal to 2. So now I'm going to evaluate this statement again because it's really important not to skip this step. We need to work out the value of x, not the value of a. So I'm going to substitute it back in up here. So then 7 is equal to 3x and 2 is equal to 3x. Okay, so now I can take this one across. He was a base over here, so he's the base of the log. So x will be equal to log 3 base 7. And in the next one, x will be equal to, he's a base here, so he's a base over there, log 3 base 2. Okay, so they're the two options that x can be.